All right, this is AP Calculus AB. We are on worksheet 5-2. This is going to be the key, the solution. So, first of all, we're just kind of setting up, practicing using Taxman, and then once we get to the backside, the backside is just kind of no setup. You have to remember how to do all of the setup on your own. All right, so first we need to identify U. U is going to be the inside. It's going to be this 2x plus 1. The inner, that's 2x plus 1. All right, Taxman. Who's knocking on the front door? 16 is knocking on the front door. So there's 16. The next, that is weird. I'll have to log that. The next question is, what is the derivative of U with respect to x? The derivative of U, this derivative of 2x plus 1 is just 2. All right, the next thing that we're going to do is we're going to pay the Taxman. So we pay the Taxman by doing 16 divided by 2, and that is 8. So when I rewrite this is now going to be the integral. Oh, it's actually, I rewrite it down here. This is now going to be the integral of 8 instead of 16. And then it's going to be times 2x plus 1 to the power of 3 dx. Now I actually take that integral. So here we go. When I do that, I get, maybe I'm going to do it out here to the right. I think I need some more room to simplify. This is going to be 8 still times quantity of 2x plus 1, all that to the power of not 3 anymore. I'm going to add 1, it becomes 4, and then divide down by that 4. So all of that divided by 4. And don't forget your plus c. Let's see if I can move that over with technology a little bit so it's a little bit easier to see. There it is. All right. And then from there I need to simplify. So my final answer is going to be 2 instead of, because 8 over 4 is 2. 2 times quantity of 2x plus 1, all of that to the raised to the power of 4 plus c. And there's our final answer, box it. And I kindly gave you an area to check your work. So let's take the derivative. If I take the derivative of this function, I should go back to 16 times quantity of 2x plus 1 to the power of 3. Let's check. And this is just letting you know, if you're on the test, there is a way to check your own work. There should always be. So if I'm taking the derivative of this function, that is going to be equal to, well, the 4 comes down in front, so it's going to be 4 times that 2, and then it's going to be all that to the power of, or all of this quantity of 2x plus 1 to the power of, it goes down a power. Remember, whenever I take the derivative, it goes down instead of up, so down to the power of 3. But I have an inner, which means I have a dinner. I did doubter. This was all doubter. Now I need to multiply this by dinner. The derivative of 2x plus 1 is times 2. Is that actually equal to what I started with? Well, 4 times 2 times 2 is 4 times 4, which is 16. And yes, the leading coefficient should be 16. This is to the power of 3. I can give myself a check. Woo! We got it. And it's good practice to know how to take the derivative to go backwards and forwards, to connect those two in your minds, how to go backwards and forwards. Let's do number 2. So number 2, I'm going to first find U. U is this inside, this x minus 3. Taxman, there isn't a Taxman. So I'm going to treat this as if there is an invisible 1. It's a ninja Taxman. 1. And then I take the derivative of U, the derivative of this, and that is also 1. So when I pay Taxman, I'm going to pay Taxman 1. I'm basically paying him himself, right? So now that we've paid Taxman, it's going to look the same. It's still this integral of x minus 3 to the power of 3 dx. We can actually take the derivative or the integral very easily, the antiderivative. So I still have this x minus 3 on the inside. This is now to the power of not 3. I'm going to add 1, it becomes 4, and don't forget to add your c. And there is your answer. How do I check my work? Well, when I take the derivative, and this is not very formal of me, I should say, the derivative of x minus 3 quantity to the power of 4, all that stuff, I'm just going to say the derivative is equal to save space here. When I take the derivative, the 4 comes down in front, I'll get 4 times x minus 3, and then it goes down a power to the power of 3, and then the derivative of c, I forgot to say it back here, but it does cancel out. It's just a derivative of a constant. And do I have to worry about a dinner? Well, the derivative of x is 1, so I'd really be multiplying by 1, which I don't need to show. Is that what I started with? No, because Mr. Sindel made a mistake. Raise your hand if you found it. I'll log it.
Let's go. Yeah, I don't have a log sheet.
You guys don't have a log sheet?
Yeah, but I don't have any. Well, I have that old one, but you want to use this?
If you guys could pass that new one around. There's your log sheet. Yeah, we forgot to divide down, didn't we?
Yes. Troy, you can wait your turn.
All right, now let's take the derivative. See, we checked our work. That was me providing you an example.
I got it.
4 comes down in front, so it's now going to be 4 times the quantity of x minus 3, all of that to the power of 4, still being divided by 4, and the derivative of c is gone. Now we can clearly see that those cancel out, and yes, that is exactly what we started
You never
with.
signed my extra credit thing.
I can come around and do that. Wait, from last semester? Yeah, it doesn't count anymore. You're too late now. As a warning to everyone, turn in your extra credit tracker by the day of the final. I did ask you guys.
You said, oh, I'll check it later. You never did.
I said multiple times you need to have your extra credit tracker with your name turned in before the final, at least by the day of the final. Same thing will happen this year. It's a good learning lesson. It's only 1 point. Let's do number 3. So u is going to be 5x minus 7. Chris. You can't throw things in here. U is 5x minus 7. Thank you.
Why can't we throw paper in here?
5x minus 7.
It's not gonna hit anybody.
One of the rules is keeping your hands and feet to yourself. I'm hoping that we're adult enough.
That's not your feet.
Hands and feet and objects is technically the rule, but yes.
Well, like he didn't throw it at me.
At anyone, but you're still throwing things, which is not keeping that object to yourself. If you have a concern about the rule, if you think it might need to be changed, you can always talk to me later. Taxman is going to be 10 in this case. The derivative of u is going to be 5. I'm going to pay Taxman the rate of 2. So come down here. Taxman is now turned into a 2. Oop, what happened there? 2 times the quantity of 5x minus 7. That's all going to be raised to the power of 4 still, dx. Now I can take the derivative. I leave the inside the same, so it's still going to be a 2. I still have this 5x minus 7. That's still it's not to the power of 4 anymore. I'm going to add 1. It becomes 5. And don't forget to do plus c. And I forgot to divide down last time. Let's not do it this time. Divide down by 5. And, I mean, if I just extend this line, that is an answer. It is the answer, not an answer. And we can box it. I can make my box look slightly, wow, what's going on here? Slightly better. Let's check it. So if I take the derivative, that means the 5 is going to come down in front. It's going to be 5 times 2 times the quantity of 5x minus 7. And that's all going to be divided by 5. And the derivative of c, that goes away. And this is going to go down to the power of 4. These 5s will cancel out nicely. I'll use a different color to show that. Those 5s cancel out. And do I have any dinner if I take the derivative of the inside? I do need to now multiply by 5. Multiply by 5 because the derivative of 5x minus 7 is 5. And I get a coefficient of 10. Hey, and I get a coefficient of 10 to begin with. So I'm going forwards and backwards, check my work. Cool, give myself a check mark. I gave myself an X mark last time up here, but I eventually turned it into a check mark because we eventually got it correct. Moving on to number 4. All right, so again, finding u. The inner thing is going to be 3x plus 2. 3x plus 2. And I do Taxman, again, it's hidden, so it's 1. The derivative of 3x plus 2 is 3. So I'm going to pay Taxman 1/3. Let's go ahead and pay Taxman now. Taxman has been paid 1/3. This is now going to be multiplied by the quantity of 3x plus 2 and parentheses to the power of 6 dx. When we take the antiderivative, this is still 1/3. I still have the quantity of 3x plus 2. I am now going to go up a power to the 7 and divide down by that 7. Divide down by that 7. Don't forget to do plus c. Let's go ahead and simplify that a little bit more. This is actually equal to, I'm just going to put that 3 and 7 together on the bottom. So I still have 3x plus 2 to the power of 7 all over 21 plus c. There's our final answer, nice and simplified. When I take the derivative to check my work, I'm going to come down here. The 7 is going to come down in front, so it's going to be 7 times the quantity of 3x plus 2. It goes down a power to the power of 6. That's all going to be divided by 21. Derivative of c goes away. Don't forget to multiply by your dinner. This is Dowder that I just found. Multiply Dowder by the dinner. The derivative of 3x plus 2 is 3. So multiply by 3. And 3 times 7 is 21. The 21 and 21 will cancel out. I guess I should be using a different color. And I'm left with no coefficient out front. And hey, I started with no coefficient out front. I can give myself a giant check mark. I have checked my work. Let's move on to number 5. Now they're going to get a little bit faster because we know what we're doing. So there are going to be 3 things that we find. We find u. U in this case is x squared plus 1. We need to find our taxman. I abbreviate with tax and say taxman is 16x. I'm nervous because I have a variable, and I can't pay taxman a variable rate. Hopefully, when I find my u prime, I should be able to cancel out that variable. The derivative of u prime, is 2x. 2x. When I pay taxman, all right, the x is canceled out, and that's equal to 8. So I'm not paying taxman a variable rate. That's the whole concern that I had. So my new integral is going to be 8 times the quantity of x squared plus 1 to the power of 3 dx. Let's go ahead and take the antiderivative now. When I take the antiderivative, that is going to be equal to, and I have all of this room, so I have plenty of room. This is still an 8 out front. I still have an x squared plus 1, and this is no longer a power of 3, it's a power of 4. Divide down by the same power of 4, and don't forget your plus c. Simplify the 8 and the 4. This becomes 2 times the quantity of x squared plus 1, still to the power of 4 plus c. Final answer, and box it. Not the best box. I guess I can make it nice and square like that. All right, on to number 6. I'm going to switch things up. I'm going to use U-Substitution because I want to practice that. U-Substitution. I need to find 2 things. And I'm just randomly deciding. I'm not doing it for any reason aside from I need practice. U-Substitution, I still need to find u, which is x squared minus 7 in this case. Now I need to find du dx. So the derivative of u is 2x. My next step is I'm going to solve for dx. So again, I'm going to cross multiply, and I get, I guess I'll say 2x times dx. On the left side, cross multiply, and I get 1 du, or just du. And then solving for dx, I get dx by itself is equal to 1 over 2x times du. All right, now I'm going to substitute this dx, this x squared minus 7, out for a u and a 1 over 2x du. Here we go. This new integral becomes, I still have, I'm going to rewrite everything, 10x out front. But now the inside changes. This is no longer x squared minus 7. This x squared minus 7 is u. So I'm just going to write u here, times u to the power of 4. I don't need parentheses. I can drop it because it's just u to the power of 4. And then this dx now changes to 1 over 2x times du. So times 1 over 2x du. I'm worried again, just like I was worried before with taxman. I'm worried because I'm dealing now with multivariable calculus, which is not ever taught in high school. That is definitely a college level class. Multivariable calculus meaning there are multiple types of variables. I have an x and a u. That's why I'm scared. Hopefully things cancel out where I'm dealing with single variable calculus. Let's see here. I have x, 2x, and this 10x cancels out and leaves behind a 5. So when I simplify that, I can rewrite this and say, yes, that is the integral now of 5u to the power of 4 du. Okay, not multivariable calculus. Let's take the antiderivative. When I take the antiderivative, I get 5u, go up a power to the power of 5, divide down by 5, plus c. And finally, all we need to do is simplify by canceling out those 5s. And substituting u back in. U was x squared minus 7, which means this u right here is x squared minus 7. So our final answer is x squared minus 7 plus c. Box it. And maybe I'm thinking to myself, wow, U-substitution is really easy and maybe I should do taxman. Personally, I'm thinking, wow, U-substitution, I need to practice that more, which is why in number 7, I am going to try to use U-substitution again. And it has been pointed out by much of the class that that is not the right answer. The right answer, I forgot, to the power of 5. So yes, the 5's canceled out, but I should still have this x squared minus 7 quantity to the power of 5, now correct, plus c, and I'll box that. James, yes.
Would it work the same way as the other way?
Yes, taxman, you'll get the same answer. And you'll have very, very similar things that happen. Like when you get a 5 out front, that means that you were supposed to pay taxman a variable rate of, actually you'll be paying taxman a variable rate of 1, I think, if it cancels it out. I'll sign it right after I'm done with this or if the bell rings. Let's do number 7. What time do we get out of here? We get out of here at 52. Oh yeah, I'll keep recording at another time. All right, number 7. We have this guy. Let's go ahead and use U-substitution again, like I just said. U is going to be this inner. It's going to be 2x to the power of 4 plus 13. When I take the derivative of U with respect to x, that is going to be 4 comes down. 4 times 2 is 8. X goes down a power to the power of 3. Derivative of 13 is 0. So there it is. Now I'm going to solve for x. I'm going to cross multiply du times 1 is just du. And then on the left-hand side, I have an 8x to the power of 3 dx. Divide both sides by 8x to the power of 3, and that isolates my dx on the left-hand side. I now have 1 over 8x to the power of 3 on the right-hand side. I still have that du. And I know some people might be thinking, well, can't you just put the du up here and not over there? Yes, you could. It's just how I like to do it. From here, I'm going to do my substitution. So my new integral is still integral of 24x to the power of 3. I'm nervous because that should hopefully go away, times the quantity of u. I mean, this whole thing is u, so I don't really need parentheses there. It's really u to the power of 5. And then that dx right here is going to turn into all of this, actually. 1 over 8x to the power of 3, 1 over 8x to the power of 3 du. And yes, okay, check this out. So these x cubes do indeed cancel out. 24 divided by 8 is 3, so this new integral is going to look like this. This is going to be the integral of 3 u to the power of 5 du. Okay, cool. We're not in multivariable calculus. We're doing good. Let's go ahead and take the antiderivative. The antiderivative, this is going to be 3u to the power, because it goes up 6, and then I guess I can write it closer, u to the power of 6, and then divide down by 6 and add c. Okay, I need to simplify that. I'll come over here, and that is simplified. With u being substituted back in again, our u was 2x to the power of 4 plus 13. So this is going to be 2x to the power of 4 plus 13, all in parentheses. All of that is still to the power of 6. I didn't make the same mistake. And this is now being divided by 6. Don't forget your plus c. Plus c. Just squeeze it in there. All right, and for 8 and 9, taxman doesn't work. So I'm only going to show it on number 8, and then you can kind of imply that's going to happen in number 9, and then I'll show you how to actually do it. So let's try taxman, right? Okay, I see inner. The inner, so I say u, the inner is x squared plus 1. The taxman, there is no taxman, so we assume it to be 1, and therefore u prime, the derivative of that is 2x. Let's go ahead and pay taxman. This is going to be equal to 1 over 2x. Oh no, we have a variable. And that's kind of where you have to stop. And you might be thinking, well, I'm gonna be logical, but I don't see how that's logically bad. And it really comes from U-substitution. U-substitution, you should have gotten rid of the variable to switch all over to the u's, but you haven't. You still have a variable rate. So how do you get rid of it? And there is no way. So it doesn't work. It's a variable rate. We stop here. Can't pay a variable rate. I'll write it in the notes. Can't pay a variable rate. So how do we actually find this thing now? Well, we actually have to square this, and you should hopefully remember this roughly from Algebra 2. When we do this thing, and I think even in Algebra 1 we might slightly touch on this, we do a general rectangle, or you can FOIL it out if you're fancy-pantsy, or if you remember the shortcut, that's even faster. The shortcut is the fastest way to go. I have x squared plus 1 on the top, x squared plus 1 on the left. X squared times x squared, and I'll do a different color for the inside. X squared times x squared is x to the power of 4. 1 times x squared is x squared. Down here is x squared as well. 1 times 1 is 1. All right, so I add up the area, and the area adds up to x to the power of 4 plus 2x squared plus 1. And the shortcut again would have been to square the first, and that gets here, double the product. So the product of x squared and 1 is just x squared. So double x squared, double that product, and you get 2 of those x squared, and then square the last. Square 1, and it's 1. So square the first, double the product, square the last. That is our shortcut. So now that we have rewritten this into this, now we take the integral. So this is what our new integral looks like. Our new integral is the integral of x to the power of 4 plus 2x squared plus 1, all of this in parentheses, dx. Okay, we can actually take the antiderivative. Let's switch back to blue. This is going to turn into x to the power goes up to 5, divide down. This is going to be plus 2x goes up a power to 3, divide down. This turns into goes up a power just to x, and divide down by 1, divide by 1. Nope, just leave it. And then plus c, done. I guess I could have just done that in red. Let me switch the color since that's the final answer. And we go ahead and box it. Ooh, that's not the best box. There's a better box. All right, and then for number 9, you can kind of see that it's not going to work. So there is no taxman, so the taxman would be 1, and then if I take the derivative of the integral, I get 3x squared. So I would be paying taxman a variable rate. Again, that doesn't work. So I'm going to kind of skip over that step and just show you how to actually do it. Again, you're going to be using a general rectangle, so you're going to have your box here. And let's actually do the shortcut. So I'm going to square it. Well, let me write down the shortcut in the notes. So I'm going to square the first, double the product, and square the last. I'll do cursive L so it doesn't look like one. Square the last. So the first was x to the power of 3. If I square that, it turns into x to the power of 6. If I find the product first, then we'll double it. If I find the product of 1 and x to the power of 3, it's x to the power of 3. And then double that, it's 2x to the power of 3. So 2x to the power of 3. And then I square the last. 1 squared is 1. So my new integral becomes the integral of x to the power of 6. Ooh, that's a bad 6. X to the power of 6 plus 2x to the power of 3 plus 1. And that's all still multiplied by dx. dx is like the thickness of those slices, right? That's why we always put it there. And then we take the antiderivative. So I think I can switch to red. Oh no, we're going to have to do a little bit of simplification. So this is going to be x to the power of 7 divided by 7 plus 2x to the power of 4 goes up a power and then divides down by that, plus x plus c. And simplifying that 2 and 4 really quickly, that's x to the power of 7 over 7 plus x to the power of 4 divided by 2 plus x plus c, and there is our final answer. All right, that concludes Calculus Worksheet 5-2.